Problem 4 says that the radioactive element carbon-14 has a half-life of 5,750 years. Now, a scientist determined that the bones from a mastodon had lost 65.4% of their carbon-14. How old were the bones at the time they were discovered? Well, this is an exponential decay model. We have carbon-14 decaying. So an exponential decay model, I'm going to write it like this. A of t, the amount after time t, is equal to A naught. That's the original amount. Now, if I was working with populations, I would write P instead of A. But A is going to be the amount of carbon-14. So that's the original amount times E to the negative KT. And I'm writing negative KT because we have a decay model. Now, the first thing we're going to have to do is find K when the half-life is 5,750 years. Now, we have a formula for the half-life, which is T is equal to ln2 over K. But we're looking for K. So let's multiply by K. Well, that'll give us T times K equals ln2. And now I'm going to divide by T, so I'll get K is equal to ln2 all over T. Now for us, we're going to get K is equal to ln2 over T, and that is going to be the 5,750. Now, when I did that on my calculator, I got 0.00012. So our formula is going to be this. The amount of that carbon-14 after T years is A naught, the original. That's what we're looking for. E to the negative, because it's decay, 0.00012 T. Now, in our particular case, A of T, this is the amount, all right, careful here. A of T, this is the amount left. Now, what we're told is that the mastodon had lost 65.4. All right, so what we're having is this, that A of T is going to be 100% minus 0.654, right? It's 100% minus 65.4%. So that's going to be the 1 minus 0.0. Let me see if I can actually do this. It's 1 minus 0.654, and that turns out to be 0.346. So our equation is going to be this. Now, A of T, be careful here. This A of T up here, this A of T, that is the amount that is left. So it's not just 346, it's this. It's 0.346 of times the original amount, which is not P, but A naught, all right? So it's 34.6. See if this makes sense. It's 30, how much is left? This is how much, this is the amount right here. That's the amount. Now the amount is 34.6 of times the original amount. All right, so here's what we've got. We've got 0.346 of the original amount is equal to the original amount, E to the negative 0.00012 T. All right, so here's what we have. The amount, which is 34.6% of the original amount, is equal to the original amount times this exponential. So let me just clean this equation up. Here's what we have. 0.346 A naught equals A naught E to the negative 0.00012 T. Now I'm trying to find T. I'm going to divide both sides by this A naught, right? That's the original amount. But if I do that, right, if I divide by A naught, if I divide the left side by A naught, it cancels. If I divide the right side by A naught, it cancels. It looks like this. 0.346 A naught divided by A naught is equal to all right, the right side, A naught e to the negative 0.123012 and a t divided by A naught. The A naughts cancel. And I'm left with this up at the top here. 0.346 is equal to e to the negative 0.00012 t. We can solve this for t. It's an exponential with a base e. Take the ln of each side. So I'll get this. The natural log of, I'll write in parentheses with that decimal, 0.346 is equal to the natural log of e to the negative 0.00012 t. So this will give us a natural log of 0.346 is equal to, now on the right side, the natural log of the exponential is just the exponent. That's equal to negative 0.00012 t. I can solve for t if I make that division. So t is equal to this quotient, the natural log of 0.346 divided by negative 0.00012. So on my calculator, I'm going to press the log key. I get a parentheses, put in 0.346, close it right above the 9, divide. Now, you have to press the negative key. The negative key is at the bottom right, so you're going to press this key. At the bottom right, you get a negative, and then 0.3 zeros and a 1, 2. Now, when I did that, I got this. I got 88.44 and a decimal, but this is the number of years. I'm just going to keep it like this. 88.44 years. So how old were these bones when they were discovered? They were 8,844 years old.